Hi guys, how we doing? I hope you're all doing okay. Today we're going to talk about applying the law of sines. So you're going to do a couple of problems together and then you'll have time to practice on your own. So we've got here two sides of a parallelogram, measure 27 centimeters and 32 centimeters. The included angle is 48 degrees and our job is to find the length of the longer diagonal of the parallelogram to the nearest centimeter. So probably a good idea to start by drawing a picture. We're told it's a parallelogram. So that's always how I draw my parallelograms. You can draw them however you'd like. To kind of make it match up, the shorter side is 27 centimeters and the longer side is 32 centimeters. And the angle that's been included meaning in between, right? Between those, definitely the acute angle based on how I drew this parallelogram is 48 degrees. And our job is to find the length of the longer diagonal. Well, you can kind of see the longer diagonal is this one. That one's going to be longer than the short one here. So this is our question mark. This is our x. What is that equal to? Well, you might actually see that the parallelogram is made up of two triangles. So I just kind of drew this top part over here, and this side is 27 centimeters. If this is 32, then up here is also 32, right? Because we've got parallel sides are congruent in a parallelogram. And the next thing that we're going to need here, we're trying to find x. This is a triangle, right? But don't know anything about the angles. You might think for a second that the diagonal here will bisect the angle, but that is not true. This should be a big star in your notebooks, that diagonals of parallelograms do not bisect angles. So if the diagonal doesn't bisect the angle, this can't be 24 and 24, we might be able to find out something about this angle. If we have a parallelogram, the total number of degrees in a parallelogram is 360, and in a parallelogram, consecutive angles are supplementary. What does supplementary mean? They add to 180 degrees. So if this is 48, we can find this angle by doing 180 minus 48, and that gives us 132. This angle is 132 degrees. That top obtuse angle is 132 degrees. So now, looking at the triangle here, you don't have to draw the triangle. This is just an option just to kind of illustrate what's happening. But now we've got a triangle, three sides, one angle is unknown, and the angle three triangles, one unknown side. And the angle that we have corresponds to the side that's unknown. So we can use the law of cosines. Law of cosines says c squared equals a squared plus b squared minus 2ab times the cosine of angle C, where the side and the angle match up, they correspond. So if we're going to plug this in, we know that x and 132 are going to match up as our C, and 27 and 32, those can be the other two sides. So x squared equals 27 squared plus 32 squared plus 2 times 27 times 32 times the cosine of 132 degrees. This you can plug into your calculator and you'll find that x squared is equal to some big number like 2905, something like that, with a bunch of decimals. And when you square root both sides, you'll find that x to the nearest whole centimeter would be equal to 54 centimeters. The longer diagonal is 54 centimeters.